Assalamualaikum and good afternoon respected listener and everyone. Today our group will present our topic analysis of noise and interference in IoT based smart agriculture system towards 6G. This topic focus on how modern farming use Internet of Things technology and the communication challenge that affect its performance. So throughout this presentation we will discuss the IoT smart agriculture system, the problem caused by noise and interference, their impact on farming operations, and how future 6G technology can provide better solutions. So now, I will begin with the introductions. Firstly, we have to know what is IoT. So IoT or Internet of Things is a network of devices connected to the internet that can collect and share data automatically. For example, a soil moisture sensor can send data to a farmer phone, so the farmer can monitor the field without being there. Next, we have to know what is a smart agriculture. So, smart agriculture commonly use IoT and sensor to make farming more efficient, such as automatically turning on the irrigation when the soil is dry. Next, we have to know the objective of our presentation. So the objective of our presentation is to analyze and how noise and interference affect IoT communications and how 6G technology can improve reliability and performance.
Hi, now I'll be explaining about the IoT-based smart agriculture system. So, first of all, the sensor will collect the farm data such as temperature, humidity, soil moisture, and also the pH value. And then the IoT device will transmit the data through a wireless network. Then the cloud server that receives it will store it and process the information. And lastly, the farmer will use the dashboard to monitor the condition and make better decisions on how they want to produce their agriculture system. Next, I'll be explaining about the communication technology used for the IoT to transmit the data to the cloud so that it can be safe and be processed. First, we have Wi-Fi, which is a high-speed communication for local farm networks and greenhouse. Next, we have LoRa. LoRa is a long-range, low-power communication for sensors spread across large field, which is very suitable for our agriculture system. And lastly, NB-IoT, which is cellular to IoT connectivity with wide coverage.
Explain the concept of noise in IoT-based smart agriculture systems. Noise refers to any unwanted electrical or electromagnetic signal that distorts the original data transmitted between IoT device and communication networks. There are several types of noise in smart agriculture. These include thermal noise from electronic circuits, atmospheric noise caused by weather or conditions such as lightning, electronic noise generated by sensors and communication modules, and impulse noise from agriculture machinery and power equipment. The presence of noise can negatively affect 6G smart agriculture networks. It may cause corrupt sensor measurements, increase the bit error rate, reduce the signal to noise ratio, lower communication reliability, and increase energy consumptions due to retransmission. In conclusion, although 6G offer advanced communication capabilities, noise remains a significant challenge that can reduce data accuracy and system performance in smart farming environments. Interference occurs when multiple wireless signals operate on similar frequencies, causing communication disruptions and performance degradation. Common sources of interference include nearby Wi-Fi networks, Bluetooth device, other IoT sensor, and electromagnetic interference from machinery and power lines. The effect of interference in IoT communication include packet loss, unstable communication links, and lower network reliability. The impact of noise and interference on smart agriculture operations. When sensor data becomes inaccurate, farmers may receive incorrect readings. This can lead to delayed irrigation control, data transmission failure, and reduced automation performance. Higher operational costs and lower crop productivity. For example, a soil moisture sensor affected by interference may incorrectly report the soil is dry. As a result, The irrigation systems may activate unnecessarily, causing water wastage, increase energy consumption, and reduce farming efficiency. To address this challenge, future 6G systems will incorporate solutions such as AI power error detection, intelligent spectrum management, ultra-reliable low-latency communication, massive machine type communication, and advanced beamforming techniques. In conclusion, minimizing noise and interference is essential to ensure accurate sensing, reliable communication, and efficient design making in future 6G-based smart agriculture systems.
To overcome the effect of noise and interference in IoT-based smart agriculture system, several current solutions are used to improve communication performance and reliability. First, error correction coding or ECC is used to detect and correct errors that occur during data transmission. This helps improve communication accuracy and ensure that the data received by the system is correct and reliable. Second, between antennas are used to enhance signal strength and coverage. This reduces the signal loss caused by noise and allow more stable communication between IoT devices and the network. Third, channel allocation is an important technique where different frequency channels are assigned to different devices. This helps minimize interference between multiple IoT nodes operating in the same environment. Fourth, filtering techniques are applied to remove unwanted signal and noise. This results in cleaner data transmission and improve the overall reliability of the system. Looking to the future, 6G technology is expected to significantly improve smart agriculture system. With an AI assist communication, the network will be able to communicately optimize performance and manage interference more efficiently. Ultra-low latency will be enabled, faster response time, which is very important for real-time applications such as smart irrigation and monitoring system. Higher reliability will ensure that communications between sensor and code server remain stable and accurate. Massive IoT connectivity will also allow a very large number of agricultural devices to connect at the same time without affecting performance. Finally, better interference management in 6G will reduce signal conflict and improve overall network efficiency. In conclusion, IoT-based smart agriculture play an important role in modern farming by enabling automated and real-time monitoring of agricultural conditions. However, noise and interference remain major challenge that can degrade communication quality and affect overall system performance. To address this issue, techniques such as an error correction coding, filtering, and channel allocation are commonly used to improve data transmission reliability. In the future, the 6G technology is expected to bring major improvement by offering higher reliability, lower latency, and better support for massive IoT connectivity. As a result, smart cultural system will become more efficient, stable, and suitable for large-scale implementation. Thank you.